Alright, so we've got Unit 11, Day 1. Brand new unit, y'all. So, this first section, okay, it's talking about, well, Day 1 is talking about linear transformations, and in particular the vertical translations. So basically what this is doing is it's talking about moving linear functions up and down, up, down, up, down, up, down, all that good stuff. So to get things started, what we're going to talk about is the linear parent function. And the linear parent function is basically the overarching, all-encompassing, everything comes from this function as far as the lines go. And this is the equation for it right here. Okay, we got f of x equals x or y equals x. Okay, and then if we look at it on a table, it's going to be 0, 0, 1, 1, 2, 2, 3, 3, and it goes back the other way as well. Negative 1, 1, negative 2, negative 2, negative 3, negative 3. And it kind of looks like this. Okay, and then we can draw a line just like that. Okay, now this is the function that all the other functions basically spawn from. We can sit there and we can adjust this single function to make it look like all the other functions, all the other lines. Okay, now it says that we're going to go into our calculators and look at 2x plus 3. Alright, and then it says to move the cursor until we see the kind of like a D-pad looking cursor. Click and drag the line. What changed in the equation? Okay, so what we can do, okay, is bring up our calculator here. So we bring up our calculator right here, okay, and we're going to type in 2x plus 3. Here, let's go ahead and zoom in on this so we can all see that. Alright, so we're going to look for 2x plus 3. Alright, and then we're going to put our cursor right over it until we get our D-pad insignia. And what we can do, okay, is whenever we move our cursor around now, it's kind of attached to it. Okay, but you'll notice that we're moving it up and down, basically, right? Okay, and you'll also notice that the only thing changing is our b, basically, our y-intercept, this number on the end, our constant. Okay, that's important. That's what changes in that. Now, vertical translations. Now, if we do the same thing and we graph x plus 3 and use Control G, then we can graph x minus 5. Okay, how would you describe the change? Okay, so what we're going to do is we're going to go and we're going to hit Tab, and we're going to do x plus 3 and x minus 5. Right? And there they are. If you notice, x minus 5 moved down a bit. They're parallel, and all it did was just move down 8 slots, basically, right? So what can we pull from this? Well, it says if vertical translations or shifts are caused when the y-intercept changes. If b increases, then the line is shifted up. Okay? If b decreases, then the line shifts down. Okay? Alright. So now it's going to ask us to graph some of these, you know, just kind of go ahead and graph them. So number 1. Oh, and then describe the transformation from the graph. Okay, very simple. Okay, so we go ahead and we graph f of x, which is just x. So that's going to look like, oops, that's going to look like that, okay? And then we're going to graph x minus 2. So that's going to be down here. Alright. And then we pull a line across there like that. Okay? And all that we'd have to say, okay, is f of x was translated down 2 units. Okay? Alright. Next up, we got number 2. Pretty much the same thing. Same process, same idea. Alright? We're going to start off at negative 4. We're going to go up 3 over 1. Up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay? Same back over the other way. Okay? And then we can go ahead and pull a line across there. Just like that. Alright? And now we can go ahead and do the same thing for the other. Okay, 3x plus 3. So we start off at 3. Okay? So let's see, and we're going to go up 3. 1, 2, 3. Right there. And then 1, 2, 3. Here we go. 1, 2, 3. Right there. 1, 2, 3. Right there. Okay. And we go ahead and pull our line across there. Oops. Come on. There we go. Okay. So there's that. Okay. I know they're not exactly parallel because I'm really bad at drawing things, but point stands. Okay. How far up did it, or how far down did it move, or up rather? My fault. 1, 2, 3, 4, 5, 6, 7. Up 7. Right? Not too bad. Alright, next up. Okay. We've got negative 2x minus 4, and we've got g of x minus 2x minus 1. So, we're going to start this first one at negative 4, and then we're going to go down 2 over 1. Right there, right there, right there, right there, right there, and right there. Okay, we can go ahead and pull ourselves a line across here, just like that. Then we're going to do the same thing for the other line. Start off at negative 1, and we're going to go down 2 over 1, over 1, over 1. Like that, and like that. Okay, so now I can go ahead and pull myself a line across here. Just like that. And now I'm set. Okay, and now I can tell how far it went. Okay, so I started off with this one. So now I'm going to go 1, 2, 3. So we say that we moved up 3. Very simple. Okay. Alright, number 4. Okay, if we look at this, okay, we're going to start it off at positive 2. We're going to go up 1 over 2, up 1 over 2, up 1 over 2. Right there, and right there. Okay. So there's that. Okay, and there we go. Pull it across there like that. I got off kilter somewhere in there. Okay. 1 second. There it is. Okay. So, let's see. Get rid of this line right here. Throw away. Okay. And then, let's see, there it is. Okay, right there, and right there. Okay, sorry about that. So, then I'm going to pull a line across here like this, and there's that. So, now I'm going to start off at -5, up 1 over 2, up 1 over 2, up 1 over 2, and I'm going to pull my line across here like this. Okay? Now, looking at this, I go 1, 2, I moved 1, 2, 3, 4, 5, 6, 7, down 7. So that's not too bad. Pretty easy stuff. Okay? Next up, okay, we've got problems that are just straight up, okay? Doesn't have a graph or anything, okay? So what we can actually do, okay, in order to figure out how far it moved is subtract this from this. So basically we're going to subtract the y-intercepts from each other. So we're going to do the second y-intercept, minus the first y-intercept. Okay? And that's going to be 6. So it moved up 6. Okay? Now, over here, okay? Second one, which is 0, okay? Minus the first one, okay? -5. So that means down 5. Okay? Same concept, okay? 2/3 minus -4/3. That's going to be 6/3. So it's up 2. And then, let's see, 2/5, and like I said a second ago, that's a 0 on the end. So 0 minus 2/5 equals -2/5. So down 2/5. Very simple. Okay? Now, number 9. Okay, what is the new equation if the function 1/2 x minus 8 is shifted up 4 units? So what we're going to do is we're going to add 4 to the -8, and it's going to be 1/2 x minus 4. Alright? Now, number 10, it's asking what is the new equation if the function f of x equals -2/5 x minus 5 is shifted down 6 units. So we subtract 6. So that's going to be -2/5 of x minus 11. Okay? And we can put a g of x on the front if you want. Okay? Alright. A florist charges $25 for a vase, plus $4.50 for each flower. The total charge for the vase and the flowers is given by f of x equals 450x plus 25. Okay? How will the graph change if the vase's cost is raised by 40%? So what we're looking to do, okay, this is how much we're charging per flower, so that's going to stay the same. Okay, but what is going to change is this right here. So we're going to do 25 times 1.4, and that'll give us the cost of the vase now. So we do 25 times 1.4. And that's going to equal 35. So we say plus 35. And that's the answer. Alright? Alright, now, these 3 problems right here give people more trouble than anything I can think of. Okay? Now, the parent function is always going to be a line that passes through the origin with a slope of 1. So you can go ahead and plot your parent function on here. Okay? It's always going to have a slope of 1, and it's always going to go through the origin. Okay? So we're comparing this line right here to the parent function. Okay? And as you can see, it's moved up 2. Okay? If we have our parent function drawn on this one, okay, I know that's not exactly precise, it's just kind of a quick sketch. Okay, we move the parent function down 1, 2, 3. So down 3. Okay, again, our parent function. Okay, goes like this and like this. Okay, and we moved it, let's see, that's 7, so 6. So up, or we moved that one up 6. And there we have it. Okay? Last page. Okay. Which of the following shows what happens to the graph of y equals 3/4 x if 3/4 x becomes 3/4 x minus 3? Okay? So, let's see. Let's scroll through these real quick. So, as we all know, we're wondering about this graph right here. That's the important one. Okay? Well, and it's asking what does this graph look like essentially? Okay? So, let's see. We know it's going to cross at -3, so that's gone, that's gone. Okay? And this one's gone. Okay? We need something that crosses at -3 and has a slope of 3/4. So 1, 2, 3, 1, 2, 3, 4. So 3, 4, check. Good. Has to be H. Done. Okay. Number 16. Okay. If the y-intercept of the function y equals 1/6 x plus 5 is changed to 4, which of the following correctly describes the graph of the new function? The graph of the new function is perpendicular to the graph of the old function. If the y-intercept of the function is changed to 4. Okay, so the new function is y equals 1/6 of x plus 4. Okay, so the graph of the new function is perpendicular? Nope. Perpendicular, it should be parallel. Okay, the graph of the new function and the graph of the old function have the same x-intercept. Well, no, that's not going to work because the x-intercept of this is going to change because we changed the y-intercept as well. So that doesn't work. So the same graph of the new function and the graph of the old function have the same x-intercept. Nope, should be different. Okay, the graph of the new function and the graph of the old function have the same y-intercept. Well, it just spells it out for you right here. The y-intercept of the function is changed. So, no, that's a big no. The graph of the new function is parallel to the graph of the old function. That is true because 1/6 and 1/6. Same slope, must be parallel. Alright, last one. The graph of a line is shown below. Which equation describes the new line obtained by translating the given line 5 units up? So, let's see. Our slope is -1, 1, 2, 3. -1/3. Okay, so that means that we can get rid of F and H. Those are gone. Okay, now we're going to, let's see, the given line 5 units up. Okay, so it originally crosses at -1. So that means we're going to go 1, 2, 3, 4, 5. So we're going to cross at 4 now. So we're going to have to go with G. Okay? And there we have it. Thanks for watching.